Okay, we're going to go ahead and get started. Thank you all for joining us. We are excited about some new smart manufacturing technology that we have developed for the CAMWorks product here at Geometric. And we'd like to introduce you to that technology. Before we do that, let me mention that we are going to have a question and answer session at the end of this presentation. So if you'd like to type in your questions, you can do that on your GoToWebinar control panel. So feel free to type those questions in as you think of them during the webinar. And at the end, we'll have a question and answer session. And any questions we don't get to, we will answer by way of email after the presentation. So thank you very much, and let's get started. Let me go ahead and introduce also on the line with me. My name is Mark Bissell. First of all, I'm the Senior Applications Engineer for Geometric. And with me on the line is Jim Foster. He is the Vice President of Sales and Marketing for Geometric. And Jim, I heard you there. Are you with us?
Yep, I just wanted to help get started. Hey guys, as we get started, Mark had mentioned we'd like to show you some new stuff in CAMWorks, and that's true, but also I think there's a bigger story to really take a peek at today, and that's there's a fairly disruptive change that's taking place in the connection between design and manufacturing right now, and it's one that's been kind of building for a long time, probably more than 20 years, and one of the great things about this disruption is it'll seem pretty natural. And there's a lot of industry efforts going on right now to help this transition take place. So as we get started, I think you'll see some things that look like a very natural transition, but it's happening at a very quick rate right now. So feel free to start moving forward, Mark.
Okay. So we're going to be discussing a little bit later the new tolerance-based machining that we're introducing to CAMWorks 2016, and this new technology is going to be available to all CAMWorks users at no extra charge. It's going to become available in one of our next service packs here very soon, and so we are excited about this new technology and making it available to all of our existing CAMWorks users. And Jim, maybe you'd like to go ahead and
So we look at the slide Mark just showed you. What you saw was some 3D annotations on a model. And what we're going to talk about is how the world is changing pretty quick. For many years, we've been using 3D models to make 2D drawings to go to manufacturing. And it's very typical today to give engineering or to give manufacturing a 3D model and a drawing. And one of the big efforts that's going on right now is how do we save the time it takes to make those 2D drawings, but still get perfect manufacturing done. And that's one of the big trends right now is to get rid of 2D drawings. Mark, I can't advance that. Okay, and as we see what's happening is engineering would like to go directly to manufacturing without making a drawing. And historically, we'd make this 2D drawing that might have a 3D model associated to it and send that to manufacturing. And there's technologies in SOLIDWORKS to actually put all these 3D annotations right in a solid model so that you can actually give this directly to manufacturing. And what they would have is a standard tolerance block and then the 3D annotations that were different than that tolerance block. And they would know where to put on special tools and to be cautious about tolerances to make sure they're achieving the right quality part. SOLIDWORKS has also got a tool called Model-Based Definition, or MBD, which is a publisher that lets you capture those annotations and title blocks and tolerances in the context of a 3D model and then publish it as a 3D model, like a 3D PDF, and use this for manufacturing. And this is an exciting tool to help share that information. Some other things going on is, there's a lot of data to really discuss, how expensive it is to make a 2D drawing and how valid those drawings are or some of the challenges with them. And the government's one of the big drivers right now that would like to get rid of 2D drawings and be able to do more with direct manufacturing from the 3D information. Also, there's some wonderful initiatives going on worldwide. Here's two of the biggest ones: smart manufacturing and Industry 4.0. Both of these initiatives are really about how do we get to manufacturing quicker, how do we use modern technologies to get there, and these are very broad initiatives with a lot of exciting aspects of them. And there's one aspect that we're focused on, and that's really about using 3D information to go directly to manufacture, and not just the 3D model. Keep in mind, there's tolerances, there's annotations, there's a lot of information that can be in that model to help quality manufacturing take place. And that's one of the things we're doing, is we're using that information to go directly into manufacturing, which we'll show in just a couple minutes. So first thing we'd like to do is just get 3 simple questions answered. It'll help us understand the audience a little bit, and we'll also share the information with you guys so you can kind of see what the audience is made up of. Go ahead, Mark.
So the first question is your company currently using CAMWorks? And we're interested to know about that.
And this, we're not trying to find leads for sales. We're just trying to find out some information. Really, we'll be able to show you the poll results, and you'll see a little bit about the transition that's taking place that we're talking about, and getting a bit of a perspective on it. And we can also share the data we got from our poll on Tuesday with the webinar we did.
So let me share those results with you.
So this is very similar to our Tuesday webinar. About 1/3 of the people visiting us are CAMWorks users.
Okay. So let me go on to the next question then. Does your company currently use, or do you have plans to implement, a drawingless environment? So we're interested to find out how many of you are either doing drawingless manufacturing now or are considering it in the future. Okay, let me go ahead and show those results to you.
Oh, this is actually quite a bit higher. We have a few less people in the presentation today, so it could be based on the numbers. But we saw on Tuesday, we saw about 40% of the population that visited us was either in a drawingless environment or moving to one. So this is actually higher, 64%. And this helps demonstrate the trend of how quickly people are trying to get rid of creating drawings and move to a more of an environment where you go directly from the design to manufacture without documenting that design in a drawing.
Okay, and the last question we have for you is, does your company design their own products or your own products using SOLIDWORKS? So question is your company using SOLIDWORKS to design products?
Yeah, and in general, where our curiosity is here is if you're a product manufacturer that designs and manufactures your own product, or if you're a job shop or machine shop that is a supplier to product manufacturers. So do you design and manufacture your own products using SOLIDWORKS? Oh, this is a little bit different than the other day. And Tuesday was about 70% of the companies were designing their own products in SOLIDWORKS. And what we're noticing is that the product manufacturers are really leading the revolution to move to a drawingless environment. And the manufacturing facilities, the job shops and machine shops that support those companies are adopting this to support their customers. So we saw a little bit of a difference of 70% were product manufacturers on Tuesday. Thanks for taking the time, guys. This is very helpful information for us, and it helps demonstrate the trend that's taking place to move to a drawingless environment.
Okay. Thank you for taking the poll questions, and hopefully you can see my screen again.
So just to tell you a little bit more about tolerance-based machining, as Mark gets started. What tolerance-based machining allows you to do, it's very unique to CAMWorks right now, but you'll see some other companies trying to do parts of this. It'll be difficult for them to do the whole piece. What we can do is we can read annotations directly off of a solid model, or create those annotations on a solid model and then use them to go directly to manufacturing. And what that means is to pick out all the information you need and automatically develop toolpaths. So you should see something that's very quick in terms of programming this part, and something that's very unique and new to the world.
So let me go ahead and my SOLIDWORKS now. And hopefully you can see my screen now with a model on the screen with some annotations on it. Can you see that, Jim?
Yes. Yep.
Okay. And so here's a model with some DimXpert dimensions on the model. These dimensions were added using the DimXpert technology that's inside every seat of SOLIDWORKS. And looking at this model, you might be thinking, yeah, but we don't get models with dimensions on them. So I'd like to address that right up front, and let's do this. Let's switch over to a model which is an imported model. You'll see here on the feature tree that this is just an imported model, and it's actually a step model that I read in to the system. So this is an example of a model that has no annotations, and what I'd like to do is show you how these annotations can be added off the drawing. Now, before I do that, what I also want to mention is that not all the annotations or all the dimensions off the drawing need to be added to this model. Only the dimensions and tolerances which are unique or different than the tolerance block need to actually be added to the model. So I'm going to go ahead here and start adding those using the DimXpert, and you can get an idea of how easy it is for me to go ahead and add dimensions. Also, I can select the tolerances here, so I can input these tolerances. And so we can quickly add dimensions using the DimXpert that's inside SOLIDWORKS. We can also do things like surface finishes. So for example, I'll add some annotations for the surface finishes on these, and I can pick what view I'd like to add it to. Here I'll specify a 63 surface finish for this one, and we can add that as well. And we can also add a 125 surface finish, for example, to this one. So, okay. So you can add these various surface finishes. Let me also show you one or two more examples here. We'll go ahead and add a size dimension to this one, and let's put a size dimension for the width of this pocket in as well. Okay. And again, I can specify the tolerances here. So if I want to put in limits or bilateral, depending on what is on the drawing, I can type those in and have them exactly as the drawing is. So maybe this is 0, and we can type in tolerances like you see here. So in just a few minutes, I could go ahead and add the other annotations, and we would end up with a model that looks like this, that has the various annotations added. And again, these dimensions are only the ones that are critical and are different than or not governed by the standard tolerance block that's on the drawing. And so this becomes what we might call a critically dimensioned model. And there's a couple advantages to doing that. I mean, one is that not only for CAMWorks, and you're going to see that in a minute, is that we're able to use this information and leverage this new data, PMI or product manufacturing information, or MBD, model-based definition information in CAMWorks. But in addition to that, this can also become a critically dimensioned model that inspection can use for inspecting the part and making sure that these critical dimensions are checked. So what we're doing here is adding knowledge to the model, adding additional information to the model that can then be useful and leveraged by manufacturing. Okay. And of course, once CAMWorks is installed, CAMWorks is an add-in to SOLIDWORKS. So once CAMWorks is installed, we add a couple of tabs up here to the property manager, and we also add a couple of tabs up here to the command manager. And one of those is the CAMWorks 2016 workflow tab. So this workflow tab is where we have tolerance-based machining now, this new feature that we've added. And this new feature is going to become available in a service pack. And it's a great new functionality that's going to be, again, available to all CAMWorks users. And it's become available very soon. So using this new technology, let me go ahead and launch the tolerance-based machining and bring up the tolerance-based machining user interface. And what we'll do here, using this interface, we can do several things. So over here on the left are the different types of features: holes, countersunk holes, rectangular pockets, different types of features or machinable features on parts and on this part. Here in the center is the default strategies that are being used from our technology database. So using knowledge-based machining, we're able to automatically generate toolpaths and operations. And these are the default strategies that are currently assigned to these different features. And then over here on the right, you can see the tolerance-based machining conditions, okay? So the idea here is that I may want to use different machining strategies. In fact, I probably will want to use different machining strategies for different tolerance ranges. In other words, if a pocket is or a hole or a feature is very close tolerance, then I'm going to want to use a different strategy, different tools, different feeds and speeds, and so on to machine that pocket or feature or hole. So idea here is that the user can create as many of these ranges, tolerance ranges, as they like, and they can assign they can choose what machining strategy that they want to use for each tolerance range. So let's use this one as an example here, this 170 dimension. You can see the tolerance is -0.2 plus 0.1. That means the total range of the tolerance is 0.3, and we speak of the tolerance range always in absolute terms. So it's an absolute value, always positive. So it'd be a positive 0.3. And if we look down here, you can see that that would fall into one of these two categories. 0.3 to 0.5 is the range here. 0.05 to 0.3, and whenever it falls right on one of these ranges, then it will use the tighter tolerance range, as it well should, in order to machine the pocket. And here I can also assign what strategy I want to use in order to machine that particular tolerance range. So I can choose what machining strategy, what tools, what feeds and speeds I want to use to machine that particular range, tolerance range. The other thing I might want to point out as well is the surface finishes. So we have the ability to select different machining strategies based on surface finish as well. So for example, over here, if I zoom up a little bit, you can see and you can see here the 32 finish that's here on this pocket. On this surface, a 63 finish is specified for this surface, a 125 here, and a 250. So these fall into different surface ranges, surface finish ranges, and again, I can pick the machining strategy that I want to use for that particular surface and determine what feeds, speeds, step overs, and so on that I need to use to be able to achieve that surface finish. And we can even do that based on the material. So for example, we could also have strategies just for aluminum or just for P20 mold steel, stainless steel, that sort of thing. So we could have different strategies for different materials as well, and we can select which ones we want to use. In addition to that, I can also select what color I might want to use as well. So it will actually colorize the surface as well when it finds that surface. And you can see the different ranges I have set up: 10 to 50, 50 to 100, and so on. So, and I've assigned different strategies for machining these pockets based on surface finish. I also have some settings over here to be able to automatically recognize the machinable features on this part. So we'll see that in a minute, and generate the operations. I can also sort the operations and generate the tool paths all automatically. And last but not least, I can also machine to the mean, and this is a very important part of the new feature that we're adding here with tolerance-based machining, is the ability to machine to the mean of the tolerance. So for example, in this 150 dimension, this pocket was nominally dimensioned or modeled at 150, but if I machine it to that, I'll be right on the low of the tolerance. So what I want to do is actually program and machine to the mean of this tolerance. And so this new functionality that we've added, tolerance-based machining, allows me to be able to machine to the mean as well. So it will actually open up this pocket and create toolpath that's just a little bit larger based on this annotation that we have here. So let me go ahead and say OK, and it'll begin processing. And what it'll do is begin going through the entire model and finding all the machinable features using automatic feature recognition. CAMWorks has some of the world's best automatic feature recognition, and it can automatically find over 20 different types of machinable features on parts. Once all the features have been discovered, then CAMWorks will automatically use knowledge-based machining to generate the operations, all the tools, including the tools, feeds, speeds, to machine all the machinable features that are on this part. And now with the new tolerance-based machining, the SOLIDWORKS dimensions and surface finishes will also be read, used to automatically select the correct machining strategies, and machine to the mean of asymmetric or non-symmetric tolerances. So all this is happening automatically as we're watching, and CAMWorks is great for program automation. And now with this new tolerance-based machining, we're able to read the annotations, leverage the PMI and MBD data to go ahead and generate the toolpaths and operations to accurately machine the part based on the PMI or MBD data that's in the models. So we're really excited about this new technology and our ability now to be able to read this PMI or MBD data. And it takes a minute to process here. It's just about finished. There's quite a few features on this part and a lot of calculations going on at the moment. So and we're really looking forward to a new era in terms of 3D models like you see on the screen here with the PMI and MBD data, and getting away from the 2D drawings. You saw earlier in my PowerPoint that the 2D drawings are expensive to maintain and to build in the first place or draw in the first place, and also they typically get out of date easily to the 3D models, so they often don't match the 3D models once they're passed along. And you can see now that it's gone ahead and completed the operations. And you can also see where it's colorized the various surfaces. I mentioned about how it can read those annotations, the different annotations, and colorize the surfaces that you see here. And so CAMWorks has gone ahead and done that. Let me go back to the feature tree for a minute, and let's take a look at the results of using tolerance-based machining. And we'll begin down here with the different surfaces. And so you can see here where it's recognized that this particular surface falls within this range of 10 to 50. It's a 32 finish that I specified. And so it falls within this range. And therefore, it's going to use a particular strategy. It's going to use the 0 to 50 strategy for surface finish in aluminum. This part happens to be 6061. So it's going to use those strategies automatically. Also, you'll see here, for example, like on these oblong pockets here, you can see where it's identified that the tolerance here falls within a certain range, and therefore a certain surface finish likewise is going to be used to machine that pocket. And you can see all these different tolerance ranges that have been discovered and assigned, and the appropriate surface finish or strategies, machining strategies, have been assigned to each of those features in order to machine the part and meet the required tolerance range or tolerances. So, and you can see all this is happening automatically, so that it doesn't require human interaction, calculations. This is tedious for programmers to go through when you get a drawing like this that has a lot of or model with a lot of asymmetric tolerances on it on the drawings. So this really is a time saver, and it's much more accurate than, everybody makes mistakes, and so do programmers, and so this gets away from the mistakes that can be made, and the as a result of human intervention. So then let me go to the operations page, and here we can see the operations that are used for machining. So for example, let me just highlight this pattern project here, and we'll zoom up on this surface, and you can see the very tight surface finish that has been used, tight step over, in order to achieve that 32 surface finish. If I go to the next one, you can see where it's a little more coarse, step over. The next one likewise more coarse, and the 250 finish even more so. So you can see how it's automatically assigned the correct machining strategies and step overs based on the annotations from the from SOLIDWORKS model, and using the DimXpert data from SOLIDWORKS, the MBD data. And in addition to that, then also other strategies have been assigned, and machining has been assigned automatically. If I go down a little further, and you can see also where CAMWorks has automatically generated all 7 setups that are required for machining this part. So 7 setups are required on a 3-axis machine. On a 4-axis machine, we'd be looking at 2 setups, and on a 5-axis, we could do it all in one. The advantages of having a multi-axis machine. But you can see where CAMWorks has discovered all those setups automatically, and it'll use those for the index angles automatically also if you have a 4 or 5-axis machine. So in addition, we could look at, for example, right down here near the bottom, there's a reamed. So these particular holes are specified as reamed holes. And the reason that it picked the reamed holes is because of the tight tolerance that's specified. Likewise, these on the other end. So there's very tight tolerance here, so it's going to go ahead and ream these holes, not just drill them. And it's picked that up automatically from the tight tolerance that's been assigned in the DimXpert annotations. So that's all happening automatically here. And then also, last but not least, is the machine to the mean capabilities that I mentioned. So if I choose one of these, you can see where it's automatically calculated the the difference between the tolerances and how much it needs to add or subtract from the finished machining of the pocket in order to achieve the mean dimension on each of the pockets here for asymmetric toleranced dimensions. And so here's a good example here where a very small amount has been added or subtracted in order to achieve this, and it's calculated 0.0125. That's half of the 0.025, which is the mean dimension. That's because it's going to machine that 0.0125 off each of the sides in order to achieve that mean dimension of 0.025. So you can see all these calculations are happening automatically. I can now that I've generated all that, I can go ahead and simulate the toolpath for machining. So I'll go ahead and do that, and we can watch the toolpath simulation here. And the machining of the various surfaces that I mentioned, you can see a tight step over here being used on that first surface as a result of the 32 finish that was specified, and then a more coarse step over on the next one, and the 63 finish, and likewise even more coarse on the 125, and then on the 250 finish as well. And then we'll index the part and do the machining on the other sides of the part as well. So that quickly I've been able to program this part. And for those who are not using CAMWorks, you might want to think about how long it would take to program a part like this using your CAM system, and particularly if it had asymmetric dimensions and the other surface finish annotations and the other things that we mentioned on this part that you see here in the model. So this has quite a few features on it, lots of machining operations, and likely would take quite a while to program using a traditional CAM system. But you can see how in CAMWorks I've been able to program this very quickly. So I can also go ahead and generate the G code, of course, then in order to machine the part as well. So, and I can go ahead and play it, and we can see the G code being generated now to machine the part. Okay. So I hope you're getting an idea now of how tolerance-based machining works and what it's able to do and why we're so excited about it. It's great new technology that's going to, we look forward to moving to a drawingless environment and having models that have information on them rather than 2D drawings.
So one thing to notice as you move to a drawingless environment, there's more to save than just the idea of not creating a drawing. As we look to the initiatives being done worldwide, there's a lot of support and an effort to figure out how to take this information and go directly to manufacturing. And we're in a wonderful position to help customers do this quicker than other people because, one, we can read the manufacturing information directly from the solid model, like the manufacturing features, the tolerances, the annotations, all the information needed to manufacture it. And two, we have a knowledge base on the back end, as Mark said, that can actually pick the strategies, the information, the knowledge to actually automatically develop the toolpaths to machine the part and to set it up for machining. So I think Mark's the time for questions and answers.
Not quite yet. I was going to just quickly review the benefits of using tolerance-based machining. Obviously, you're going to be able to increase your production using it. We accelerates the CNC programming and allows the users to capture and reuse their best practices. That's what Jim was mentioning with the knowledge-based machining. And first and foremost, I probably should have mentioned first, is it eliminates the cost and time associated with 2D drawings. So there's a lot of cost and effort that's required to draw and maintain 2D drawings, and so that's one of the big benefits of going to a drawingless environment. It also improves quality. You see where all the calculations were being done automatically. All the machining strategies were being selected automatically based on the annotations, both the surface finish annotations and the other annotations on the model. and it automatically calculates and machines to the mean of asymmetric tolerances. So all that helps improve quality and reduces scrap and rework as a result. So it eliminates those errors and mistakes in calculations that often occur when we're trying to program such parts. We mentioned about the machine to the mean. That's an important one, and being able to read those SOLIDWORKS MBD dimensions and automatically machine to the mean of the asymmetric dimensions is critical. And it automatically generates the features and operations and toolpaths required for CNC machining. Okay. So with that, would like to go ahead and type in your questions. We'll answer some of the questions here. We've got a few minutes to go ahead and answer questions, so try to do some of that here. And let me just look at some of the questions here. How do you define the general tolerance on the model? And so that is going to be that's in the MBD or DimXpert. You're able to add notes and annotations just like you can on a 2D drawing. And there's also the facility to be able to create a title block and a tolerance block very similar to a 2D drawing and have that as a part of your 3D model. Someone here is asking about solid edge integration in the near future. We've typically developed CAMWorks both for SOLIDWORKS but also for Solid Edge, and I would expect we will probably do the same with the tolerance-based machining. This is a good question about can the program recognize datums and run out instructions, and that's a very good question. We're in the process, and want to make this clear as well, is that this is relatively new technology that's really under development currently, and so we're excited about it, and we're in the process of further developing it. And the datums and maximum material conditions, least material conditions are some of the enhancements that we're looking to add going forward, and that's one of the ones we've identified for certain is the LMC and MMC and datums, and how those apply and how we could read those and determine how to leverage those as well. I might mention that's likewise with the with 3D GD&T or geometric dimension tolerancing. That is something that we're looking forward to developing as well, and we're in the process of working on as well. There's a question asked here about why should I choose CAMWorks instead of other software. And that's an easy one to answer. CAMWorks is a modern CAM system. It uses the latest technology, automatic feature recognition, knowledge-based machining. In short, I am able to program parts in a few minutes that can often take hours using other CAM systems. So I would encourage you, if you're not familiar with the CAMWorks, to call your CAMWorks reseller or call us. You can get more information at www.camworks.com as well, and you can look there for your reseller, your local reseller. And so I would encourage you to take a good look at the software, because it is a modern parametric feature-based CAM system, unlike traditional CAM systems. And it is fully integrated inside SOLIDWORKS or Solid Edge, and so it really has dramatic advantages over traditional CAM systems. And we're just about a little over, in fact, time. So I'm going to go ahead and wrap it up here. And I want to thank you all for joining. We certainly appreciate your time, and we look forward to serving you in the future for those that are CAMWorks users. And we hope that if you're not a CAMWorks user, that you've seen enough to hopefully get you to take a closer look at the product. We think you can benefit greatly by doing that. And also, I might mention, we will go ahead and send out answers to the other questions that we weren't able to answer. We'll provide those through email. So thank you very much. Jim, any parting comments?
Guys, thanks very much. And you know, as you look at your own environments and your efforts to speed up going from design to manufacture, it's a really great time, because there's such a big push in the industry to do that, and it's happening at a very quick rate. So, you know, 20 years ago, it was unbelievably a big effort to do, and today there's so much help doing it, and there's so much momentum going that way, that it's really reasonable to look at that. And as you go drawingless, keep in mind, it just doesn't mean eliminating the time it takes to make drawings. It's really about what else is going on to help us manufacture faster, to take design information and move faster to manufacturing. Especially product manufacturing companies, where you live and die by new product introductions, getting to market quickest, getting the best competitive edge to be profitable. And things are changing very quickly, and we're fortunate enough to have a tool that really has been set up perfect for that, with the ability to recognize manufacturing features and to have a knowledge base on the back end to set up the automatic tool paths. So again, thanks for spending time with us, and if anyone needs more information on some of the efforts going on in industry, feel free to contact us.
Thanks, Jim. And thank you all for joining, and we look forward to having you in our next webinar. Thank you very much, and bye now.